Let's review together for the upcoming algebra final, and we're going to start with question number 1, where we're going to be solving for the system of equations. Now, this one can be a little bit tricky because when we're looking at these two linear equations, I notice that we've got two variables, of course, right, a and b, and I also notice that we've got two fractions, and that's going to be a little bit challenging. So, first thing that we need to do is eliminate a variable. We're going to eliminate a, and to do that, the coefficients have got to be the same, but the signs have got to be different. They've got to be the opposite. We need a positive and a negative. So how are we going to do that? We're going to jump right on in, and I know that we're going to multiply into this top linear equation 3, because when we distribute, actually let's do that right now. So when we distribute, 3 times a is going to give us 3a. 3 times negative 2/3 b is going to give us simply negative 2b, because the 3's, of course, cancel out. And then 3 times 4, obviously, is going to give us, what? 12. Great. Now what we're going to do is we're going to multiply the bottom by negative 5. And the reason we're multiplying by negative 5 is because when we distribute, as you're going to see in 1 second, negative 5 times 3/5 a, well, the 5's cancel out, and so we're left with simply negative 3a, which is exactly what we need to eliminate that variable. And we've got to continue distributing, right? So here we've got negative 5, and we've got to distribute it into b, and that's going to give us, of course, negative 5b. And then, can't forget, we got to distribute this to the last term, so negative 5 into 15 is going to give us negative 75. All right, tremendous. Now let's take a look at these two linear equations, and we're going to be combining like terms. And when we do that, when we're looking at 3a minus 3a, it's going to be simply 0. Negative 2b minus 5b is going to give us negative 7b. Great. And 12 minus 75 is going to give us negative 63, and we are almost there, ladies and gentlemen. We're going to need to apply the inverse operation and divide both sides by negative 7. And when we do that, b is going to be what? 9. Beautiful. So we're basically halfway done with this problem. What we're going to need to do now is plug b, which we now know is what? Positive 9, back into one of these two linear equations. So let's do that right now, and we'll do it to the top one. Why not? So what I can see is actually, yeah, let's do it to the top one. I'm going to rewrite this like a minus and 2/3 b, but in this case it's going to be 9, right? Equals 4. So how can we simplify this? Well, what it's going to simplify to is a, and then we're going to multiply 2 times 9, because this is basically the same as 9 over 1, right? And so 2 times 9 is going to be 18. 3 times 1 is going to be 3, so it's 18 divided by 3. 18 divided by 3 is 6. So a minus 6 equals 4, right? And then we're going to have to, of course, subtract 6 from both sides. And add 6 to both sides, because we're doing the inverse operation, and that's going to mean a is equal to 10. And that, ladies and gentlemen, is our answer. So we can write it like a equals 10, b equals 9, and that is, that's our answer. Great. Question number 2 wants us to solve this system graphically, which means we're going to have to chart it on a coordinate plane. And this is not slope-intercept form, but very simply, we can make this equivalent of y equals mx plus b by shifting 2x to the right side of the equation. And to do that, let's subtract 2x from this side. And let's do the same thing to the bottom. We're going to subtract simply x. And when we do that, what is our new linear equation? It's going to be, the top one is going to be y equals negative 2x plus 6, great. And the bottom, of course, is going to be y equals negative x plus 3. Great. And when we take a look at these, what I know is that we've got, of course, our y-intercept right here, and this is our slope. So negative 2 is the same thing as 2 over 1. And negative x is the same thing as what? Same thing as negative 1 over 1, which we know means going down 1 and then to the right 1. So these are both negative slopes. Let's see what they look like when we chart these graphically. All right. So let's take a look at the first linear equation. I can see that it's the slope-intercept, I'm sorry, the y-intercept is positive 6. So I'm going to start right here on the y-axis. And I remember that the slope is negative 2 over 1. So what we're going to be doing is we're going to be going down 2 and then over 1. Great. And then we're going to be going down 2 over 1. And then, oops, there we go, down 2 over 1, down 2 over 1, etc., etc. Or up to 1 to the left. Great. So we've got our first slope. And let's take a look at, which we're going to connect the dots in just a second. Let's take a look at this next one. So I can see that is negative 1 over 1 as the slope, and positive 3 is the slope, I'm sorry, the y-intercept. So we're going to go up to the third dash on this y-intercept. And the slope, we remember, is negative 1 over 1 x, or simply negative x, right? These are the same thing. So we're going to go down 1 to the right 1. Great. Down 1 to the right 1. 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 Okay, and so now when we connect the dots, like so. All right. Okay. Zoom out a little bit. Okay. And of course, we've got to label these. What we're looking for when it says, when we return to this question, it says solve the system graphically. What it wants us to know is, where do these two lines intersect? So one line intersects right here. I'm sorry, these two lines intersect right here, right at this coordinate. And what is this? This is, of course, 3, 0. We know that we went to the right 3 and we didn't go up or down on the y-axis. So this right here is our solution. Bam. Question number 3 wants us to solve the systems by using substitution. That's going to be critical as we approach this problem. And let's take a look at these two linear equations. So what we're going to do is we need to determine how we're going to proceed. What makes the most sense is to figure out what the value of x is and then plug that in to this linear equation. So what is x equal to? X is equal to, if we add y to both sides, x is going to be equal to y minus 8. Great. So now we know the value of x. We can simply take that and plug that into this x right there. So what is that going to look like? That's going to look like y minus 8 plus 2y equals 7, right? Okay. So now we need to combine like terms, and what I know is that we've got 1y, or y right here, and we can add that to 2y. So we're going to have 3y minus 8 equals 7. Let's subtract, let's add 8 to both sides by using the inverse operation. And when we do that, we're going to have, of course, 3y equals 15. Let's cancel out the 3 by dividing both sides by 3. Again, the inverse operation by division. And that's going to mean that y equals 5. Great. So now we know the value of y. We've got to figure out what the value of x is. So we're going to take y, and we're going to go back to this equation, and let's extract this bad boy right there. So we're going to take that linear equation. So x minus y equals negative 8, right? I simply rewrote it. And instead of rewriting this, what I know is we're going to now plug in 5 for the value of y. So it's going to be x minus 5 equals negative 8. Let's add 5 to both sides. Great. And so, of course, 5 minus 5 cancels out, and x equals negative 8 plus 5 is going to be negative 3. And so we just solved these two equations using substitution. So question number 4 wants us to solve the system by using elimination. So we're going to have to eliminate a variable. Let's try to eliminate the variable x. And what we need, of course, are coefficients that are identical, and yet signs that are the opposite. So we need a positive and negative. What are we going to multiply into each of these equations to get it so that the x's can be eliminated? Well, when we're looking at the top, or rather, when we're looking at these two coefficients, 5 and 2, these, of course, do not cancel out. However, if we multiplied the top equation by 2 and the bottom by negative 5, that would give us, of course, 10 and 10x and negative 10x, which would then result in these variables being eliminated. So let's do that. So we're going to multiply the top by 2 and the bottom by negative 5. And so let's distribute these. All right, actually, we'll do that right there. So 2 times 5 is 10x. 2 times negative 2 is going to give us negative 4y. And then 2 times 20 is going to give us 40. Great. So now we're going to be looking at this. We're going to be multiplying negative 5 into each of these three terms. And when we do that, negative 5 times 2x is going to give us negative 10x. Negative 5 times 3x is going to give us, it's going to give us negative 15y, right? Equals negative 5 times 27 is going to give us negative 135. Great. Well, these variables can cancel out, right? 10x minus 10x is simply 0. And let's take a look at what we have left. Negative 4y minus 15y is going to give us negative 19y. And 40 minus 135 is going to give us 95. Great. Not done yet. We've got to sort of eliminate negative 19 by doing the inverse operation. Of course, is division. So negative 19's cancel out, and we're left with y being equal to what? 95 divided by negative 19 is negative 5. Great. So we just solved for y. Amazing. All right. So now what we're going to do is we're going to need to take this, and we're going to need to plug it back in to one of these equations. Let's pop it back into the bottom one. Okay. So I'm going to rewrite this top one, but instead, well, you'll see what I'm going to do. 2x, we don't know what the value of x is, plus 3, open parentheses, equals 27. So where previously there was the y, I'm now going to plug in this negative 5. Okay, great. And now let's do a little order of operations. So 2x minus 15, right? 3 times a negative 5 is 15, equals 27. Great. Let's add 15 to both sides. And when we do, the 15s, of course, cancel out, and we're going to be left with 2x equals 42. Great. Now let's simply divide both sides by 2. And when we do, 2's cancel out, and x is going to be equal to 42 divided by 2 is 21. Oh, amazing. All right, so x equals 2, and y equals negative 5. This is our answer. I'm going to write, so you could write the answer like y equals negative 5, x equals 21. Alternatively, you can write 21, comma, negative 5. Question number 5 says, Mrs. Jones bought 2 pounds of veal and 3 pounds of pork, for which she paid $20. Mr. Cook, paying the same prices, paid $11.25 for 1 pound of veal and 2 pounds of pork. Find the price of a pound of veal. Well, that's what we need to do. This is our objective. So we need to figure out the price of pound of veal and the price of pound of pork. All right, so how much does the veal cost per pound? How much does the pork cost per pound? Let's explore this a little bit further in depth. When we're looking at this first sentence, so Mrs. Jones, she bought 2 pounds of veal, and we're going to say veal is V. and 3 pounds of pork, which we're going to refer to as P, for which she paid $20. What equation can we write? So I'm going to write that like 2V, right, 2 pounds of veal, plus 3 pounds of pork, or 3P, equals 20, or $20. And Mr. Cook, this other character, purchased a single pound of veal, so I'm going to write simply V, but 2 pounds of pork, and Mr. Cook only paid $11.25. Great. So what do we need to do? We need to eliminate one of these variables so we can isolate the other and figure out what the value is per pound. So let's figure out what the pound is first of pork, and to do that we're going to eliminate the veal. So what we're going to do is we're going to multiply into this bottom equation -2, because when we then combine like terms, we can then eliminate the veal. So what are we going to be doing? -2 distributed to the V, and to the 2P, and to the 11.25. And let's do that over here. All right, so I'm going to rewrite this equation, the top one. 2V plus 3P equals 20. Great. And then we're looking, -2 times V is going to give us -2V. -2 times 2P is going to give us -4P, right? And then equals what? -2 times 11.25 is going to give us -$22.50. Beautiful. All right, so now what we can do is determine the value of the pork. So what I know is that 2V minus 2V is nothing. The veal is canceled out. And 3P minus 4P is going to give us simply -P, or -1P, equals what? 20 minus 22.50 is going to give us -2.5, or -250. And if we were to divide both sides by a -1, or just a negative sign, right, it's going to be, of course, P equals 250. Great. All right, so the pork per pound is $2.50. So now that we know the value of pork, let's plug that back into this one of these equations, and we'll figure out what the value of the veal is. Great. So what I'm going to do is I'm going to use this bottom equation, V plus 2P equals 11.25, and I'm going to rewrite that. I'll rewrite that right here. Okay, so V plus 2 open parentheses equals 11.25. And I like to put that open parentheses right there just so I can keep in mind and make sure I'm organized about where I'm substituting this variable. So instead of P, we know that P equals 250. I'm going to plug in 2.5. Great. So V plus 2 times 2.5 is going to give us 5, equals 11.25. Great, we're going to, let's subtract 5 from both sides using the inverse operation, meaning that the value per pound of veal is $11.25 minus $5. It's going to be $6.25, or $6.25. So we just figured out the value of the veal per pound. We figured out the value of the pork per pound. We just solved this question. Great. Question number 6 says, find the equation of a line that passes through the points 5, 2 and 3, 1 in any format you wish. Any format? That's amazing. So what I'm going to do is I'm going to use point slope format, or point slope form. And I know that already we've got 2 sets of coordinates, and I can simply select this coordinate or this one, and we've got to figure out the slope. This is the equation that we're going to use to figure out what slope is. I don't know about you guys, but I know when I approach these sorts of problems, the very first thing I like to do is label this. So I'm going to label it like x1, y1, and then x2, y2. Beautiful. So now what we're going to do is I'm going to plug that into this equation. And I know that it's going to be slope. It's going to be m equals, well, what's y2? 1 minus 2. Beautiful. And then 3 minus 5. And that's going to be 1 minus 2 is going to be negative 1, and then 3 minus 5 is going to be negative 2. The negatives, of course, cancel out, so that m equals 1/2. Great. And so now let's simply plug that into point slope form. Pretty easy. And I'll actually do it right underneath. So how are we going to write that? Y minus, we'll do, we'll use this set of coordinates right there. So I'm going to take that 1, and I'm going to plug it right in here. So y minus 1 equals slope, which is 1/2, times x minus 3. Great. So this is our answer. We just wrote it in point slope form, but you can write it in any format that you'd like. Question number 7 says, find the equation of a vertical line and a horizontal line that passes through negative 2 comma 9. So I know that negative 2 comma 9 is about, if we go over to the left 2 spots, then up about 9, I'm just, ballparking it. It's going to be about right there, right, on the coordinate plane. And it says we got to figure out the equation of a vertical line, which is going to be, just going to look a little bit like that, and a horizontal line, which is going to look like this. But we don't really need to worry about plotting it. We simply need to, of course, figure out the equation. So the equation of a vertical line is always going to be what? X equals negative 2. Because when we're talking about vertical lines, they're always on the x-axis. So here, when you jump over 2 spots, there's negative 2, right? But what about this horizontal line? Horizontal line is going to always be y equals, then whatever the y value is. In this case, it's going to be 9. So there we've got our answer. Horizontal is going to be y equals 9. The vertical is going to be x equals negative 2.